Do you think it is possible to have malware inside an image? Well, you're looking at code that is inside an image, and in the following video, we're going to see how to reverse this. Enjoy. Hi everyone. Do you think this is valid code? Well, it turns out it is. And it seems pretty common in this last week. I've seen a lot of malware recently that is copying the exact same payload style, where they have strange characters that get replaced with A's, and then it gets decoded into from base 64, and then they execute it. This is the full code. I just removed the parts that I didn't need to. So basically, let's jump into this, and I will show you what this has. This is pretty interesting, trust me. So first of all, I found this by just looking at the reports from any.run, which we saw in the previous video, and I was just looking around, lurking a little bit, and I found a couple of malware that had this type of payload, where we're just executing PowerShell with this payload there, and they all looked pretty similar. I spent a lot of time looking at them, reversing them, and it turned out that either the domain or the IP was down or not accessible anymore, so it was just lost time. But happily, this one right here works, and this was updated today in the morning. Now it's in the afternoon, so it's pretty recent. Let me just guide you quickly through this report. We have this WScript that's executing a JavaScript. This JavaScript file will execute the PowerShell, and this PowerShell will execute another PowerShell that will then download a file, and this file will have something interesting that we will see later. Trust me, it's very interesting. So first of all, what we need to do is just we download the sample that's been uploaded for the analysis. All right, here we have it. So we download this zip file from this page, which contains a JavaScript file. So let's open it. So we see a lot of shit code here, right? We see a bunch of variables that are being declared, like a lot of them. Then there's some code in between, and then there's more shit code in the end. Trust me, it's actually shit code. There's nothing else happening behind. So if we look at the code by just ignoring these variables in the top, we just see a couple of functions being declared, but none of them are executed except for this one right here. It's called glutinosidade. I have no idea what that means. But basically, this is the code that is being executed, the PowerShell that I just showed you. So this is the entry point of the malware. It's a JavaScript file that once executed, it will run PowerShell code. So in the end, we have a very simple code. We have variable that has a string with strange characters, and then another variable that contains the output of replacing these strange characters with A's, and then everything gets decoded from base 64, and then it gets executed in PowerShell, right? We actually don't want to execute it, obviously, so we remove the site and just go to PowerShell. We drop the code there, and then we can just log the output of this variable, right? So we do write output and then the variable, which is this. And as we can see here, again, it's another PowerShell code. Let me just put the syntax and purify it a little bit. All right, so let's go step by step, right? Okay, so first of all, we have a variable with an image URL, which is a Death Note image, and then it will just download the data from this URL. It will get the string, and then it's going to do something, right? So let's download the image first. So we go here, and it's a Death Note image. Pretty strange, right? Why would a malware want to download a Death Note image? So if we download this, I've already downloaded it here. First of all, if we open the image on Sublime Text, it will preview it. So in order to check the contents, what you do is just changing the ending of the file, and it will open it. But obviously, it's in hexadecimal, so there's no point on opening it. But as we can see from the image bytes, it's searching a string base 64 start and base 64 end. So what this means is that by the start flag and the end flag, it will get the contents in between, and then it will load a .NET assembly from in memory. Let's get there. So basically, we can just do exactly the same thing, right? We just put everything on the PowerShell. And then here we have the command bytes. We obviously don't want to load the assembly on memory, because that would mean that we're running actual malware, which obviously we don't want. But first, before doing this, let's check the contents of the image first. Right, in order to get the actual content of the image, so here we have the image text, okay? So here we go and do the same thing. We write the output of this variable, and here we see in the end base 64 end, and then wherever it begins, we have the beginning. So we have these two flags that this program is using to define the actual content that's in between, that is going to contain the payload. Here we have everything done, so we just write the output again of this base 64 command, and here we have the rest of the code. I will not decode it. I've done it on my end, and it's just like bytes. There's nothing interesting that we can check apart from just loading it. Obviously, we're not going to load it, so instead we are going to write the content of the command bytes into an actual DLL, which we can then decompile and check the actual source code. Okay, so I wrote this very simple line, which basically will write all the bytes from this variable into this file here. So here we have it. It's called malware.dll, which here we have it. And then personally, I use dnSpy. It's an amazing tool to kind of reverse engineer .NET modules. So we can just go ahead and open it here. And it's this one here. It's called dnlib for some reason. You might think, where the hell is the entry point? How can I execute this? This is the interesting part. If you go to these very 2NF last lines, we can see that once the assembly has been loaded, it will get the type, which is dnlib io home, and then inside it will get this method, it's going to search for the by method, and it's going to call it with these parameters. As you can see here, it's a reversed URL, but we can just go ahead and check it manually, right? So we go here, and then it was on the home section and the by method. And here what we can see is basically it's going to get the first parameter is going to be an array of in this case of characters or string. Basically it's the same, and it's going to reverse the URL. It's going to download the content, and whatever is contained on this website, it's going to reverse it again, and it will decode once more from base 64, and then it's going to execute it again on a .NET framework environment, and then that's where the malware is actually contained. Reversing this was not necessary, because obviously if you just look at the code, you can just see this is a reversed string. So we could just go ahead and reverse it online. Pretty simple, right? So we go here, we reverse, and then we can see it's a txt file. We go here, and voila, once more, as we've seen, it's a reversed base 64 encoded string. So we just go here again, we reverse it, we get the contents, and we decode it again. And then this is going to be an exe. As you can see, it's in DOS mode. So this is again a .NET binary, but in this case, it's an executable file, which I have it somewhere here. Yeah, malware.exe. And again, this is a file that's been done with .NET. So once more, we can use dnSpy to check the contents of this. Let me just clean this up a little bit. All right, so this is the assembly that we are looking at. As you can see, it's obfuscated, right? And you might think, how the hell am I going to know where the entry point is? Because if we run this malware file on detect_etc, we are going to see that it's been the entry point has been modified, as well as the flow control, and there's also some protections such as anti-debug, anti-sandbox, anti-VM. So this executable I would not be able to run on my virtual machine straight away, but obviously there are ways, right? But which I will not be showcasing here. But as you can see, there are a couple of things done to the binary to protect it from being reversed, which is obviously a pain in the ass. But in the end, it's simple, at least to start looking at how to start with this, basically. So on dnSpy, there is a way. Sorry, I have it in Spanish, but there's an option that will move you to the entry point. This is basically that translated into English, and it's going to move you to the very first method that's being executed once you run this file, which is this one. And this would require for an entire new video, which I will not be doing here, but we could just be reversing this entire binary. It's doing a lot of stuff, trust me. It's stealing credentials, it's a screen logger, it's a key logger. It's huge. I've been reversing it a little bit, and as you can see, there are a lot of methods, and all of them look super strange, which I'm not obviously going to be one by one. But as you can see, for example, this one, it's something related to MySQL, so it might be exfiltrating local databases. This one, something about Opera Mail, I don't know. It's 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 logging and getting as much information as possible. It would be interesting to see where this data is being sent to. Sadly, on the online analysis, given that this is a VM and this it's detecting that it's a VM, it's not running the entire code, so we cannot see perfectly where this data is being sent to. But obviously, if we would have to find it, eventually we would be finding it. It's just a matter of reversing every single thing one by one, noting everything down, and just eventually finding what would you need to find and start appropriating this malware if you can. And yeah, so that's it. Thank you for watching.